Welcome students. We are going to start part 3 of the chapter Multistep synthesis. In part 1 and 2 we have already covered elements of a synthesis, particularly reaction methods, reagents, catalysts, solvents and protective groups. In this part we are going to deal with activating groups, leaving groups, but synthetic equivalents will be covered under retrosynthesis, that is the next unit. So let us start with activating groups. The role of activating groups is quite pronounced in the case of aromatic hydrocarbons. Substituent groups can be divided into two categories based upon the manner in which they influence the reactivity of the aromatic ring. What are activating groups? Substituents that cause the benzene ring to be more reactive than benzene itself towards electrophilic substitution are called activating groups. For example, NH2 group, OH group or ether group, OR group. So, aniline will be more activating as compared to benzene due to the presence of the activating group NH2. Now, substituents that cause the benzene ring to be less reactive than benzene itself towards electrophilic substitution are called deactivating groups. For example, nitro group, cyano group or ester group. So, nitrobenzene is less reactive towards electrophilic substitution than benzene. So, nitro group is a deactivating group. Coming to next element of synthesis, that is leaving groups. It is a molecular fragment that departs with a pair of electron in a heterolytic bond cleavage. Leaving groups can be anions or neutral molecules. For example, commonly leaving groups are halides, that is ionic in nature. For example, chloride, bromide, etc. Common neutral leaving groups are water and ammonia molecules. Leaving groups can also be positively charged cations, for example, protons. So, coming back to our previous example where 2-chloropropane was synthesized from 2-propanol in the presence of hydrochloric acid, our leaving group is a neutral molecule, that is water. So that's it in this segment. See you in the next video. Thank you.